stuff, including a reading of some strange titles of papers that he may or may have not written. And for lack of an exotic seventh sphere, they presented him with 7 exotic spheres, including a coconut and a pineapple. For Jack's 67th birthday, the John Milnor Millennium Orchestra played the Children's Symphony by Mozart. For Jack's 70th birthday, that was a study group that was the time and place where the famous Misiurevich 2D picture was taken. Then in Toronto, for Jack's 75th birthday, we played Who Wants to Be a Milnorer? And then I started participating in these jokes. In Banff, for Jack's 80th birthday, we had a little presentation making fun of the names of some of the participants. And now Sarah is interested in joining the fun, so she wanted to create something. So here's a nice idea that she had. We have done everything that can be done to make fun of Jack, so she here got us to go through his books, page 85 in each of the books, and collect some of the sentences that I found there at random and create a poem. Topology from the differential viewpoint has only 58 pages. But the first sentence on page 58, which is 85, the verse very much reflects what we wanted to do. It says, the following is a miscellaneous list consisting of original sources and of recommended textbooks. And John Howard will read the poem.
So I'd like to just point out that the colored dots next to each line of our poem, that indicates the book that Jack has written from which that particular sentence came. So the key is down here for these 6 books. And I can't show it at the same time as the poem because I want you to be able to read the poem. And I've invited our distinguished Professor John Hubbard, who's very good at reading poems, to read this poem for us. Okay.
Okay. Maybe I will have the loudspeaker for the occasion. Okay. Can you hear? I am not responsible for having put together this collection, and it sure manages to make mathematics sound absurd. But here goes. Now let us begin the proofs of theorems 10.1 and 10.5. First note that lambda of tau is continuous from the left. Note that the action of W on c to the nth preserves the norm. Thus W lies in the null space. But the null space of E star star consists of Jacobi fields. An immediate consequence is the following. The correspondence L maps to t to the minus 4th G2, t to the minus 6th G3 may perfectly well be topologically attractive. Thus, the quadratic form E star star is positive definite. There is no analogous concept of a repelling basis. By the Schwartz lemma, lambda of tau is a monotone function of tau, which proves that lambda is in absolute value greater than 1, as required. It follows that the inequalities above must all actually be equalities. As an example, for n equals 2 dots, the action is determined by the formulas. Suppose now that we are given n-dimensional triads. Then we see that such sequences lying on logarithmic spirals are extremely pervasive. It is easy to check that X is given a well-defined orientation, where each G alpha is one of Steinberg generators. The reader can easily give a natural correspondence by deleting any zeros which may occur, and conversely. The proof is straightforward. I believe that I have read all of those books from cover to cover.